section, first introduce Professor Jean-Claude will introduce himself. After that, he will give his knowledge about the transportation and overall logistic exploration department. After that, next session we can ask question and answer from the professor. So please, Professor, use your time. Use yourself and then you ask.
Well, thank you first for the invitation to come talk to you. So the reason why I'm here is really that, as what you said, I'm a professor at the University of Notre Dame in Charlotte in the US. And this past spring I taught a class on transportation policy. And one of my students is actually from this university, he's on the faculty of this university. So he was telling me a lot about Indonesia, and he knew I was coming to attend a conference here next week in Bandung, and we talked a lot about it and said, well, would it be interesting to give a lecture at my university? So I said, sure, no problem. So this is the reason really for me to be here. So let me say a few words about who I am and the work that I do. So this is essentially the contents of my talk, and I'll go over these various points. I'll talk a little bit about me first and about regional science, which is basically an association that I'm president of, and the meeting, the conference is to be held here next week is a regional science conference. And how many have ever heard of regional science? That's what I thought, so I want to say a few words about that. And now I'll go over these various points. I'll talk a bit about space-time convergence. I'll talk about transportation logistics, about intermodalism, containerization in ports, and I'll talk in that context a bit about some of the work that I've been doing and what big data set I've been working with. And particularly, I'm going to make reference to some data relative to Indonesia to make my talk relevant to you and see how some of those concepts basically can practically be applied to improve your own future, basically, not just you personally, but the future of this region, the future of Java and Indonesia at large. And I'll give you some conclusions. So the conference that I will attend next week is going to be at the Savoy Hotel. So this is from the webpage of the conference. You can check it out. It's the 23rd Pacific Conference of the Regional Science Association International, so ISAI. Which is an international organization devoted to regional analysis, basically. Regional science is a branch of, I was going to say economics, but it's not in economics. I mean, it basically is sort of a cross between economics, transportation, geography, planning, statistics, very different fields that come together. And the idea is really to look at the region as a unit of observation, as an entity, as the focus really of the attention. I will tell you a little bit more about this in a few minutes. So this association has been in existence for 60 years, and there has been a Pacific branch of this association in existence for something like 45 or 46 years. This is only the 23rd conference, really, because it takes place every other year. So the last one was in, I can't remember what it was. I'm sorry. So it alternates. 1 year is a conference, and the next year it's a summer institute. So last year there was a summer institute, and I was in Beijing. And next year there will be a summer institute again. And because it's Pacific, so basically it's not just for Asia, but it includes as well the Pacific coast of North America and Pacific coast of South America. So next year the conference, or the Summer Institute, will be in Ecuador. And I think that the conference organizers expect something like 350 participants from a number of different countries. And like I was saying earlier, you're very welcome to attend. You may be asked, I guess you certainly can attend, and people may ask you, well, did you register? I can't tell you that you can come for free, but you probably can sneak in and come listen to people. There will be a lot of presentations given on Indonesia by Indonesians, and because I did look at the program the other day, there's nobody from ITB. So if you come to attend, feel free to tell people that you do exist. And in the future, feel free as well to participate in this organization. There is a section in Indonesia, it's called the Indonesian Regional Science Association. If I'm not mistaken, the president is part of is affiliated with the other university across town. Actually, when I saw that there was nobody from this university, this institute on the program, I thought, well, there must be a lot of competition really between institutions, which is not unusual. But ultimately, this is an association, both the Indonesian branch and the Pacific and the international branch, which is really not intended to foster. It's intended to foster collaboration and understanding and share ideas and research, innovation. So feel free to attend so that if you are really interested in some of the ideas I'm going to talk about in a few minutes, you can come listen to that. So ISCI is the international organization, and since this presentation I've been the president of this association, and I will tell you a few more things about it. So I'm a geographer personally, maybe a little bit of an unconventional geographer because I work with a lot of non-geographers. Actually, most of my students, my graduate students, are not geographers by training. They are computer scientists, engineers, they are a lot of different things, but very few of them are geographers. And I do research in transportation, I do research in regional science, looking at it from an economic perspective. And I do research as well in urban studies, looking at the social dimension of the development of the cities and how innovation, for instance, helps the social economic development of cities, help them blossom basically, help the proper sharing of resources and the wealth as well within the population of the cities. I'm interested in transportation from a logistics standpoint, but also from the standpoint of transportation as being infrastructure that is necessary for people to move from place to place, also for freight to be shipped from one city to another. So it basically is a very important ingredient on how a city gets structured. Most of the innovation that takes place in a country takes place in cities, overwhelmingly. It's not to put down people who are in the countryside, but basically they've been farming for generations and suddenly they do adopt new technologies, but most of those innovations that are basically created in farming, but also certainly for industrial applications, and for whatever you have, if you have a cell phone, I mean, those innovations really are created by people who basically live and work in cities. Cities are, in any country, the source of innovation, period. Now, if you politicians really don't like to hear that way, too bad, that's totally wrong. Right? Innovation takes place in cities, so cities really need to be the focus of attention. That's where education takes place, that's where most people live. That's also a source of a lot of problems like congestion, pollution, all kinds of issues, which really means that different solutions can be found to problems that emerge in cities. So regional science deals with a lot of those issues. Cities being regions, city regions. Right? Regions, well, I'm not talking about provinces, entirely rural. Actually, typical province has basically a seat of government, the place where the political power is concentrated. But it's also typically a place where most of the commercial activities take place. And those central commercial activities now are connected to what's going on in smaller towns and smaller villages scattered around the province. Industrial activities tend to take place in cities. Cities like Bandung are connected to other cities in Java and other cities in the world, other cities in the country and in the world. And that creates a network, right? A network of cities is really what we're talking about. The city as a region that is connected to others. And the relationship that exists between those places is really what regional science is about. So the Regional Science Association has in the order of 4,500 members worldwide, represented many countries of the world, particularly in the US and in Europe, but very strong in Japan. And we're working very closely with a group of researchers in China. There will be several Chinese researchers here in Bandung next week. In Brazil, they're very pushed regional science very strongly, in India, and so on. And as I was talking about regional science before my talk today, and I was really saying that one of the fundamental difference between just economic development, right, that you may have taken a class in, and regional sciences, that in regional science we put the emphasis on the fact that you can develop a country and look at it macroeconomically. That's really desirable. I'm not saying that that's not good, but you also need to pay attention to how that development is balanced around the country. Let's put it this way. Indonesia's population was around 250 million. Now, if all of the resources and all the attention of the government was on Jakarta, what would you say? That's not desirable, okay? Because Jakarta would grow to be big, too big probably for its own good, and at some point it will collapse. That is not desirable. So there needs to be some form of balance between the level of development between the different regions in a country. That's what regional science is about. Right? What kind of policies, what kind of tools can you think of adapting and putting in place to reach that desirable interaction between the regions? Looking at trades between regions is extremely important. One thing that's been, again, this is something that you probably learned that is well known among emerging countries, is that emerging countries trade with each other much less than they trade with developed countries. And all of that trade with developed countries is in terms of resources. Those are resource-based economies. And that's inherited from the colonial period, right? Where basically a lot of what manufactured good Indonesia was consuming was probably manufactured in the Netherlands, and the Netherlands was basically buying or whatever, taking from Indonesia a lot of the natural resources of the country. And that was basically a very unequal trade, right? But Indonesia was not really interacting with China or with Vietnam, is what is known today as Vietnam, or with India. And today still, pattern will see that less developed countries, emerging countries, trade with each other much less than they should for their own good, right? And there are a lot of good things really in terms of those trade relationships, really because the infrastructure does not exist today to make it possible, and the trade relationships are not in place, right? So Brazil, for instance, I mean, you all know that this is one of the BRICS countries that is emerging, that is growing very quickly. And one of the things that they're trying to do, and that's one of the reasons why regional science has taken out so dramatically in Brazil, is really they have become aware of the fact that really growing Sao Paulo, which is the economic capital of the country, much more than it is at this point, is not desirable. So you need to have a balanced development between the different states, call them states in Brazil. Regional science is really quite significant. We have several very large conferences. The North American meetings has the order of 600 to 700 participants, and that's a conference where it's very methodologically strong, dealing with spatial analysis, with statistics, with operations research as well. So that's really something. And I'm mentioning those things particularly because you being in the Institute of Technology, that's probably the aspect that you can relate to rather than the soft side of regional science. Actually, regional science tends to be very strong methodologically, which is also the reason why I thought that I was very surprised to see none of you is participating in this conference, because this is really a place where you would feel at home. The many of our conferences, spatial econometrics, location modeling being operations research models, intended really to find, to seek the optimal locations according to some pre-specified criteria for facilities, where to best locate a plant, where to best locate schools, for instance, how to design the bus routes within the city to be as efficient as possible. All of those types of considerations. European meetings is even bigger than the North American one, about 1,000 participants, so it's really very big. And then the Asian conferences, I told you, is a little smaller, 300 to 350 participants. Regional science is a field that is interdisciplinary. You will find people from many different disciplines. You find geographers, economists, engineers, planners, development experts, and so on, as I said. So my own field is transportation, urban analysis. I do a lot of work dealing with statistics. I use geographic information systems a lot, which means computer mapping, tied to particularly methods of analysis with visualization interfaces, and it's tied to computer science. That's tied as well to the analysis of very large data sets, what's known as big data. If you know about computer science, that's a very common term used today. Walter Izard, you see his name that is listed at the end of that quote, is the father of the association. He passed away 2 or 3 years ago now, and basically he wrote that quote, and I've just put it there so that you can have a chance to look at it. And he defined regional science. He said that regional science is primarily a social science, focusing upon space and systems of spaces, regions and systems of regions, locations and systems of locations. And notice that, therefore, distance is very important. Transportation is very important, because if you have regions and you really want to understand how they interact with one another, how they trade with one another, then you need to figure out really what are impediments to trade. And certainly distance is an important one, because it does cost money. It is expensive to overcome that distance. You need to ship, right? Or it takes time. Therefore, transportation is a very core dimension of what regional science is about. But also communication. These days, you can be in touch with some friends in Jakarta or in the US without going there. You may not ever have been there. Just by picking up your cell phone or by going on the internet and Skyping, right? So communication technologies may to some extent be a substitute for transportation. Okay? And to be able to leverage this is extremely important. Now, one of the things I'm going to mention to you later today in my talk is that all of those concepts are extremely important in the case of Indonesia particularly, because Indonesia is an interesting country that is big in population, but also very big in area, but also very scattered. 2,500 kilometers from east to west, 1,000 kilometers from north to south, which is kind of unusual. Basically, you have those, whatever, 30,000 islands, if I've been told. And to be able to bring them together so that you as an economy function in a way that is coherent, and that you all can interact and trade with one another, as opposed to 30,000 separate economies, which is certainly not very efficient. So regional science puts emphasis on the regional context, the region, the geographic entity. Without predefining them, they are not necessarily provinces or political entities. When you know that in the US we have 50 states, and actually those states are political entities, are not necessarily very good to reflect the economic reality. My city is the city of Charlotte, and I'm right at the border between North and South Carolina, right at the border. And actually the metropolitan area spills over on the other side of the state, right? Those are state boundaries, which means there are no customs and things like that. You can freely cross the border, and these are states, not countries. But this is a very good example of the functional region of Charlotte is actually very big. It's 15 counties or so, about 2.5 million people, if I'm not making mistaken. That's about the population of Bandung, but spreading over 2 states, right? And that's the way it is. So functionally, really, we have a region, an urban region that covers basically 2 states, and that's not that unusual in the US. Okay? New York City. Well, New York City is right at the very start, or very tip, basically, of New York State. And actually, the functional region of New York City spills over multiple states, including New Jersey, including Connecticut. So it's really a multi-state region. That's the way it functions. People commute across state lines. Many businesses actually claim to be in New York while actually they are in New Jersey, because for tax purposes it's better for them, more advantageous, they pay less taxes. Right? So the political entities don't mean much. Right? Politicians may want you to believe that that's the case. Well, I mean, I'm not saying that we need to get rid of those political entities. I mean, that's not, you can't change the political boundaries all the time. You just need to live with the way they are. But the reality of economic relationships, and community relationships, and functioning of cities and regions is that often they transcend boundaries. One last example, Hong Kong. Hong Kong is not really a country, but it's not even a region, because actually most of the economic relationships between Hong Kong actually spill over the boundary between Hong Kong and mainland China. Hong Kong doesn't make anything anymore. Not quite, but not much. Right? Most of what is manufactured by Hong Kong companies is actually made across the border, Dongguan, Shenzhen, Guangdong province. And there are very close relationships there between Guangdong province and Hong Kong. Very close relationship. Many of the headquarters of the companies, the marketing offices, the financial offices, the R&D will be done in Hong Kong, and manufacturing is done across the border for cost considerations. So there's an interdependence between the two. Right? That's the way it is. Definitely. It functions as a very large region. All right, so region science looks at the link between micro, which means the local and the regional, and the macro, the national and the global. It looks at regional impacts of national policies, and looks at the region as a holistic entity. One of the reasons why I think that saying that region science is part of economics is way too narrow is really because it does involve many other dimensions. It involves the social, the human, certainly the economic, and the social would be, for instance, in terms of human capital, social capital, how people relate with one another, education, and a lot of the intangible things that are part of, that aren't strictly part of economics. The environmental component as well is very important. The resource components, infrastructures as well. So it's multidimensional. And the fact that all of those facets come together in the regional context is really what makes regional science unique and different from other disciplines. All right. So some of the things often discussed in regional science, themes of innovation, regional growth. What can you do to promote regional development or regional growth? How important is innovation into this? For instance, research institutions, like ITV, for instance. How can you encourage more research and development, patent applications, basically, right? At the forefront of research in the region. What do you need to do about this? What can you do about this? Are the relationships between businesses and universities and other government entities successful and fruitful for this? Issues of urbanization and agglomeration economies. The reason why cities are the places, and cities I don't mean the political definition of it, I believe in the functional urban region, are the places where most things happen in the world, is really that's where businesses like to locate, because they take advantage of what I call spillover effect, agglomeration economies. If you locate in Jakarta, then you have access to a zillion other businesses that you can tap into, and you don't have to. You can place an order 2 hours later. I mean, basically, that's going to be delivered in your office in your factory. While if you were to locate 5 hours away, then you may have to wait a day or two before the part, before the computer, for instance, the replacement computer that you need to be delivered. So it is really that great assets and great advantages from being located in one of those urban areas. So that's what I mean by urbanization and agglomeration economies. That's the reason why businesses tend to locate there. But the downside is that it tends to be much more expensive, but that's the price to pay for access to that network of knowledge, right? Companies do not provide a lot of their own services internally. Typically, they rely on other businesses to provide them with basic services, accounting services, logistics services, all kinds of other services that they buy on a regular basis, lawyer services, and so on. Okay? The downside also is congestion. So agglomeration leads to congestion, leads to pollution and all kinds of detrimental aspects, and that's definitely something that's been dealt with to maintain the attractiveness of cities. And that may be one of the reasons why as cities grow too big, or that there's something that growing too big, in the sense that if you grow too big, that these economies of scale may outweigh the economies of scale. Okay. Typically in cities, you will find better education, you will find much better healthcare, cultural facilities, entertainment facilities, something that particularly the young generation is looking for. If you want to entertain, if you want to have fun somewhere, you don't go in the countryside. Most people don't. I'm not saying nobody does, but most people don't. You go into the city. Okay? And that's also the reason why people who live in the countryside may come to the city really for entertainment. But that's where things happen. And typically, the bigger the city, the bigger the opportunities, and the better the things that you can do, I guess. So what regional science, and there is something that is joined with geography, says that space does matter. Regions do matter. Things that happen regionally do matter, in spite of the fact that today, with internet and with mobile communication, you can be in touch with things happening at a great distance, but space still does matter. We do interact with much more with people who are in our own vicinity, in our own city, than with people who are further away. Now when we talk about space, there are different kinds of spaces. Now I'm going to say a couple of things on this. One of them is what's called the absolute space, and that's if you had a geography class in high school, you learn about longitude and latitude. Well, that defines geographic space, the map that you see. Okay, places are referenced by longitude and latitude. That's an absolute space that is not changeable. Okay? Those coordinates are never going to change. Well, actually, because the continents move so slowly, yes, they will. Over thousands of years, that will change, but we're not talking about that. So it's a space that is objective, and that space is a container in many ways, right? The land is where it is. It is what it is. You may say, well, it's a shame that Indonesia is that collection of 30,000 islands. Well, that's the way it is. Okay, you can't put those islands together. It's not going to happen. Okay, just live with it. Okay. Another notion of space that is fairly old as well is the notion of relative space, and relative space is quite different from absolute space. It's a space as it is lived and as it is used by agents, economic agents, human agents. It is the space as it is a construct. It's defined by relations and by behaviors, like relationships between individuals, people, businesses, and so on. And two countries can be next to one another and actually not interact at all with one another. Think of the Koreas, North Korea and South Korea. Well, they share a border, but they don't have anything in common, except ethnically they have the same people, the same language, but because of the border, because of the political situation, well, it's just as if they were 5,000 miles. Well, I guess they wish they probably were 5,000 miles away from each other. They're not. Which does create some problems too. Okay? Now this is a map of Indonesia, and certainly that is a good reflection of this thing. I mean, you're spread over 2,500 kilometers, but you're one country, you share a lot, you're one economy, one government. So relatively you feel that you're part of that entity that you really want to grow in a unified fashion. Right? And certainly regional science would be one element of this. Regional science is not intended to grow the islands as separate from one another. It's potential to grow them together by allowing them to grow prosperous, independently, but also together with one another, and develop relationships with each other. Right? So regional science is not intended to encourage the partitioning of countries. That's not what it is about. Okay? It's totally unrelated to the political reality in many ways. We're talking about functional relationships here. So let me move on to that discussion of space-time convergence. And actually, the transition from Indonesia to this is really very good, because while 2,500 kilometers may seem like a lot, but actually today, because of airplanes, I mean, it can go from one end of the country to the other in a matter of, I don't know how many hours, but a few hours, right? 100 years ago, it would take you days to do it. Okay? And that's really what I'm going to talk about here when I talk about space-time convergence. It's that notion that over time, space is shrinking, basically. That is something that is enabled by technologies, by communication and transportation technologies. So technologies that seem to erase the function of distance through movement acceleration. There is indeed an acceleration of movement in that respect. But the physical distance cannot change. 2,500 kilometers, that's going to stay, okay? But the time it takes you to travel from one end to the other is over time shrinking, okay? And certainly, if you pick up the phone, it's instantaneous in the fraction of a second, okay? That's the extreme space-time convergence. And often this is represented basically by a globe that is shrinking, because it's not just the case of one country, but it's a scale of a globe that is progressively shrinking, and it's almost like a point in many ways. Now for the shipment of freight, we're not quite there yet, but certainly in terms of communication between individuals, that's where we are. Because indeed we can communicate, and certainly if you go back to the 1500s, the days of the prior to the Industrial Revolution, to what we have now, I mean, you have that fundamental evolution of the ability to link up different parts of the world. And this chart, just to illustrate this, is the number of days required to travel around the globe, to circumnavigate around the globe. And the date over here is 1850, and then on the right you have the present. In 1850, it took 350 days, so it was a one year affair, basically, right? And now it's basically in 1 day. Yeah, I guess in 1 day you can, maybe not. It depends on what you travel on. Shipping mail, this is an example of shipping mail between New York and San Francisco between 1840s and 2000. And again, this is in one country, so from the west coast to the east coast of the US. 1840, this is before the completion of the rail line across the continent. So it took a long time, so it took 30 days for mail, a letter, right, to be shipped from San Francisco to New York. Right? And now it's basically a day or two. The US mail is fairly efficient. Right? Americans like to complain about that mail operation, but actually it's very efficient. And other examples, essentially, fundamentally what we see is that over time, from the 19th century, and you can go back further in time if you wish, okay, to present day, on the right over there, you see that declining curve as new technologies have been adopted, bringing people and places together much more readily. All right, I thought that this one was a very interesting map when I picked it. The shortening of air routes between London and Sydney from 1955 to 2006, and because the map is tipped so that London is here on the left, Sydney is on the right, and what I liked is Jakarta was a major stage basically in that route. It is not anymore. Okay, Jakarta is bypassed in many ways. But sorry. So in 1955, the Super Constellation, which was I think the first jet that was used for international connection, it took 2.5 days and 7 stops. All those hubs, they're from London to Rome, to Cairo, to Dubai, to Colombo, Singapore, Jakarta, Darwin, and finally Sydney. 2.5 days, 70 passengers. And now you can go in one single swoop on a Boeing 777 in 20 hours. I don't know about that. I can tell you that from Chicago to Hong Kong, it was 15 hours. So there was no direct flight to Jakarta, but so that's about right. So that's quite a bit faster and carrying many more passengers at once. Okay? So that's really what we're talking about, that shrinking of the globe. But also notice that a number of locations have lost potentially significance. Jakarta is not a point where the planes have to stop anymore. Okay? So if you don't have to come to Indonesia, you can skip Jakarta. That's the reality of it. All right, so that space-time convergence can be measured. I mean, I did tell you that region science likes to measure and uses equations. And the idea is that over time, basically, there's a shrinking of the amount of time it takes to travel between two different places, and that's represented through these equations. So from A to B in 1950, it took 6.2 hours. In 2000, it takes 2.6 hours. Then the difference, you can calculate it over there, which is, what is it? I'm not going to calculate it. Divided by the number of years in between. And this is basically a measure of the space-time convergence, the pace at convergence, basically, of space through time. So it's 0.072 hours per year. I know that it's not constant because innovation doesn't happen continuously. It does happen by leaps and bounds very much. So this is often represented by that blow that progressively shrinks, and that has very significant impact on the way people interact with each other. If you live in Bandung now, if you want to go to London or to Amsterdam or to New York, it's going to take you just a few hours. Again, a couple of generations before you, it would have taken many days to do that at best. So now it's possible for you as individuals to travel much faster, for businesses as well to ship things back and forth, which has led certainly to the Industrial Revolution. The Industrial Revolution has been very important in this, in the sense that it has made it possible for the world trade to dramatically increase. Before the Industrial Revolution, it's estimated roughly 3% of the global trade was actually, that global trade was, international trade was only 3% of the world output, total world production. And now it's a third. So a third of what is produced worldwide is actually trade between countries and often at great distance. There's a much greater interdependence, economic interdependence between places. Countries used to be much more autonomous from one another, disconnected, and certainly it's true that countries did used to trade, but really very marginal, very small amount really of their wealth and what they used to consume was really imported. Now it is really a very significant proportion. So the economic interdependence is great, which means also there is a great degree of specialization of countries. Being a generalist is not part of the picture anymore. Countries that want to produce everything are really missing the boat. Okay? There's a lot of population migration that is happening at great distance within countries, but also between countries. And this has certainly a number of consequences in terms of the origin of those flows, but also the destination. What's going on at the destination in terms of human social capital in both locations. I'm going to skip just a couple of things. These are two maps of the U.S. This on the top there is only the eastern half of the U.S. to the Mississippi River. Here is the entire map of the U.S. And these are maps, the lines have been drawn there showing the amount of time it took in 1830 on top to travel from any location to New York City, which is the dots there on the right corner. And you see that actually, so I live, I can't reach there. I'm not tall enough. Anyway, over there in the border between North and South Carolina, it took about 4 days for anyone living in my town to travel to New York City in 1830. In 1857, and this is really the result of the first rail lines that were built in the US. So I live right there. And now all of a sudden it took just about 2 days to travel between the two. So the travel time between New York and Charlotte has been cut in half in a matter of 27 years or 30 years. Okay. So the shrinking of the globe. And notice that, so those curves have been moved dramatically to the left because of the expansion of the transportation system. That's what transportation does to you. It makes it possible for more people to interact much more readily, much faster at low cost. So infrastructure is very important. It's an enabler. You cannot have a developed economy without good transportation infrastructure. It's a requirement. It's a precondition. I'll come back to that. Now, space is very plastic, fungible, and malleable as well. And this is the reason why I talked about the notion of relative space. This is an interesting view where you see a hand that basically is stretching the US just as if it is a rubber sheet, basically, right? And it is the result of the fact that over time, the transatlantic connections, the ships basically crossing the Atlantic, were able to cross much faster, which almost closed the gap between North America, US particularly, and European continent. That's an example of that convergence that we've been talking about. Okay. This is relative location. Okay. North America and Europe are the two biggest trading blocks in terms of connection, trade connections between the two. Okay. And that's a reflection of the fact that indeed transportation is not an obstacle anymore, it is relatively cheap. There are dozens of transatlantic flights, maybe, I don't know the exact number, between all of the airports in North America and the airports in Europe. So flying is very easy. There are all kinds of high-capacity ships carrying 15 or 17 or 18,000 containers at a time, flying the seas of the North Atlantic Ocean. So indeed, it is a major trade corridor. There's no doubt about it. Now, even Europe is very small. Actually, I don't have a scale over here, but your country is just as big as Europe from east to west. Just keep that in mind. So when the Dutch come back here, just tell them that basically they're actually only a small part of Sumatra. Just tell them that. All right. On top, so the previous map was a physical map of Europe. And this is a map of the rail connection in terms of time connection by rail in 1993 on top. And again, that map, because the rail system at the time was fairly uniform, pretty good, pretty well developed, but there were no high-speed rail lines yet. It started in France. And over time, they really built even more. And basically, this is the situation that is anticipated in 2020 with the full completion of the high-speed rail system. That's what transportation does to you. While Europe is small to start with, it's shrinking. Okay? It's almost as if you were to draw a map of Europe with a piece of paper and basically crumble that sheet of paper and it becomes a ball. Okay? You can travel from any place to anywhere else very quickly without effort and at fairly low cost. That's what transportation investment does to a country, to a region. Okay? All right. Yeah, I'm going to skip that. All right. I want to say a few words about world cities, because world cities are basically places where things do happen at the scale of the globe. Those are the places that tend to be very well connected, headquarters of big companies and so on, but also the places where things that tend to be very well connected on the transportation system. World cities tend to have major airports, to be close to major ports. So there is a lot of transportation infrastructure that enables businesses, but the residents as well, to travel very quickly from place to place. Actually, in many ways, they do create a certain high-level tier, basically, of the global infrastructure. Notice Jakarta is listed over here. It is listed as yellow dots. It's a second-tier city. It's not the first tier, but it's a second-tier city. But there are a number of other cities in Asia that are first tier, like Tokyo and never about that. Shanghai is not. That's just all kinds of ranking and ratings and maps and scoring systems of world cities. So I'm certainly not going to say that this one is the best. But I wanted to show you basically there is a whole system, a network of world cities that are connected through transportation infrastructure that enable the CEOs of companies basically to travel quickly from place to place. Airports, big airports really require, because it's very expensive infrastructure, a lot of traffic, so they tend to be located where there's a big market. And themselves, they tend to as well concentrate traffic from hinterland. So there's a whole network of feeder lines and feeder routes that feed into those hubs of the transportation system that is anchored on to the world cities. Now, one of the themes of regional science is that there's a relationship, a close relationship between transportation and spatial organization, where things happen, what regions develop and which ones do not develop. And this chart sort of shows that relationship. And this is a model that was developed some time ago by a geographer called Jean-Claude, so it's called the Jean-Claude model. And the idea is the following. So how do you get into sort of that circuity of the relationship between those different elements? Well, so the relationship between transportation basically and development and growth in different places. Well, it starts in, I guess, I'm going to start here, but ultimately it keeps going around, so it doesn't stop ultimately. You could start somewhere else. But you start basically by having demand for accessibility in cities. The demand for transportation. There's a need on the part of businesses, on the part of educated people for travel, because travel is what is necessary for interaction between individuals, to share ideas, to sell your products, for scientists, for instance, to come talk to others and other locations and so on. So there's demand for accessibility. We are asking for better accessibility. Demand for transportation. So if you look at it from a social perspective, we mean from the perspective of society, that means that at some point, and for better accessibility, there would be a search for technologies that can to meet the needs. And if you look at airline companies, airplane companies, and railroad companies, and car companies, and so on, they keep developing new technologies that enable us to travel faster, better. Civil engineers basically build better bridges, better highways, and all of those things that enable us basically to travel faster, more safely, more reliably, with less congestion and things like that. So there's a search for new solutions to the problems that exist of insufficient accessibility. So development of technology is really very central to this. And certainly if you go back to the early decades of the Industrial Revolution, that's what happened with the invention of the railroads, for instance. And later on, the automobile, and then the airplanes, and all of those things, right? So that's been transportation innovation, which has been applied in those areas, which has led to space-time convergence, as I told you before, discussed that. Space-time convergence means that it's easier and cheaper, faster to travel between places. So there's a spatial adaptation to the change in travel time, leading to concentration and specialization. I'm sorry, centralization. If there is really very poor transportation, cities tend to be very decentralized, really, because you can't produce as much in Jakarta as you do now, because it would be very expensive to ship to the different provinces. So the scale of production has to be very decentralized. Okay? It's only because transportation became cheap, physically cheap, and financially cheap, that indeed centralization became possible, right? Centralization and specialization, the results of that technological evolution resulted in reduction in transportation costs. As a result of this, we have increased interaction, because now that you concentrate more production in the big places, you need to ship that to the rest of the dynamic space that you interact with, since things are produced at fewer locations. So there's increased interaction between places, which means more transportation, more demand for transportation. If there's more demand for transportation, there's more demand for accessibility, which basically is going to reinitiate the cycle. And essentially over the past 2 or 3 centuries now, we've been going through this cycle many times. And that's ultimately a lot of what explains the change in the geography of production, the geography of urbanization as well in all parts of the world, as a matter of fact. So a consequence of this is a long-term decrease in friction of transportation. So if you have distance over here on the horizontal axis, if you have the amount of interaction on the vertical axis, Early on in time, you had basically a relationship that was represented on the first curve. Over time, the curve flattens, basically, so we have more and more interaction on great distance. Okay. It's clear that 50 years ago, if I had lived 50 years ago to be a professor, I would not be here talking to you. Okay. Because the cost of me coming here would have been prohibitive. There's no doubt about it. Okay. I can be here for 2 weeks, it's affordable, I can do it. In those days, I would not have been able to do it. So the amount of interaction has increased because of the reduction in friction of distance. The result is lowering of the average ton-mile cost of transportation and a decrease in the importance of transportation costs. There's no doubt about it. In spite of everything that I've said that transportation is central to everything is organized. The fact as well is that transportation is less important now than it used to be before. 50 years ago, most of our lives, most of the business of companies was very localized. And now you have big companies that produce worldwide, that ship worldwide. That didn't exist then. So the scale of production is a result of all of this, ultimately. And that's what is represented in this diagram. I'm not sure you can see that, but basically the different locations, and for market, C for L for production of location of production, C that's an input. Basically, you have 3 different products that are produced locally. There's one market that is common. There's one that basically brings together those locations, M1, C1, and L1, and M2 that is in blue. There's another one in red, there's another one in yellow. But basically, you have 3 production sites, L1, L2, and L3. And with the reduction in transportation costs, then you get into a model where you don't need those 3 plants anymore. And one is enough. Out of one location, you can take advantage of economies of scale and produce at one single location. And you locate yourself right in the center of all of those markets you can serve. And that's really very important. That's also the reason why some more remote locations have become, in the modern production system, totally unnecessary. Small plants have closed and only big ones are surviving at locations that are more accessible. Now, Janelle, in his model as well, what we talked about, aside from what I described here on the right, is what is here on the left, which is that as you increase interaction, there's also an increase in congestion that occurs, right? An increase in congestion may lead to actually space-time divergence as opposed to convergence, which means that the city of Jakarta, even though it is really not that big, but it takes 3 hours now. I'm being exaggerating. 2 hours to cross Jakarta from east to west. That was my experience the other day. Maybe 2.5 hours. That's a case of divergence. That's not what cities are supposed to be about. That's a case of a city that is becoming dysfunctional. That's my own experience of it. That's not what cities are supposed to be. Cities are supposed to provide better accessibility. Unfortunately, in many parts of the world, cities can, if there's not sufficient transportation investment, this is not hopeless. Okay? If there's no sufficient transportation investment, that's what you have. That's the point. There needs to be continued transportation investment in order to keep up with the increased demand for transportation. Typically, and these are different cities in the US, Atlanta, Baltimore, Columbus, and Louisville, before 1957, so this is in the early days, I guess soon after World War II, and this is the situation now. Typically, with the expansion of the transportation system, and in the US, that means the freeway system, interstates, highways, basically. The business centers have progressively decentralized, multiplied, particularly in the suburbs. These centers used to have primarily one business center, and over time they have multiplied and built some new ones, particularly in the suburbs, and particularly around rings, perimeters around. City center is still there, but it has become largely, in some cities at least, dysfunctional or unnecessary, and really because the peripheral locations are just as accessible as the central location. In 2001, Cross wrote a book about the depth of distance, and it was a very provocative title. Basically, was saying, well, you know, with communication, with the increased access to transportation technology, distance doesn't matter anymore. And many people who work in the spatial sciences, in geography, in regional science, will scramble to find an answer to all of this and say, well, is it true that distance doesn't matter anymore? Well, yes, distance does matter. Right? It still does matter, but very differently. It's true that transportation costs are not as important, but really, if you look at the places that really mean something that's significant in today's world, in the global economy, globalizing economy, only the locations that are well connected really do matter. If you're not well connected, if you're not on a global transportation network, you're losing. You're a loser. That's the way it is. We don't like the word, and mayors and so on do not like to hear those words, but that's the reality. You need to be on the network. Either communication network or transportation network. If you're not on it, you're losing proposition, period. I'll come back to that in the context of Indonesia too, basically to say what that means. So yes, it does matter. It does matter still a lot. Okay? And it really means that transportation matters in a very different way. Now, it is not in terms of the geographic accessibility, but the transportation accessibility with respect to the infrastructure. Okay? Transportation network is what basically is going to grant to space value and accessibility. You may be close to the airport, but ultimately, if you don't know where the entrance gate to the terminal is, it serves no purpose. Right? So you may be just 1 kilometer away, it serves no purpose. It is really very interesting because one thing that I've been here in Bandung for 2 days, and one thing that I've realized is how painful it is for pedestrians. Because you may want to go across the street, but if you want to cross the street at 4 or 5 in the afternoon, you're out of luck because you may wait there 2 hours to cross safely. So you may be very close, maybe 20 meters from where you want to go, but you're still nowhere. Right? Because you don't have a bridge over the street and you don't have pedestrian crossings to do it. But ultimately, it is the transportation network that's going to create that accessibility. Right? So that's really what it is about. All right, and notice, because now the rest of my presentation will be much more squarely on transportation and infrastructure per se. When you talk about transportation and logistics, we all know that different modes of transportation, we can typically, hypothetically at least, use a variety of modes of transportation. You can ship by road, you can ship by rail, you can ship by water. By water is obviously very important for Indonesia. And the costs are very different as well. And if the 3 options are available to you, I think it's fairly well known that typically on short distance, the cheapest would be to ship by road. On medium distances, it's typically cheaper to ship by rail, and on great distances, it's cheaper to ship by water. Now, in the case of Indonesia, obviously because of the islands, even if it's on short distance, if there's no bridge between the islands, you have to ship by water anyway. Okay? But that's a hypothetical model based on basically the intrinsic cost structure between the modes of transportation. Now, I don't know what those cutoffs, the D1, D2 values would be in Indonesia, but typically in the US, this would be about 500 miles, 750 kilometers basically. So up to 750 kilometers is cheaper and more convenient to ship by road. Beyond that, train becomes an option, freight train. Okay. And interestingly, that explains, I mean, you know, the US is a very big country. So that's the reason why actually a lot of the freight in the US is actually shipped by rail, not by road. It's part of the fact that if you look at movies, you see a lot of trucks on the highway. Well, that's only a small fraction. I think more than 50% of all of the freight is shipped by rail in the US because of the great distances. That's in contrast to Europe, for instance, that is basically much smaller, much more compact. And in Europe, 3/4 of the freight is actually shipped by truck because the distances are much shorter. Different modes of transportation have different advantages different advantages, but so the cost structure is very different. On the high end, you have air cargo. On the low end, you have water. Water is the cheapest. So you in Indonesia, you may say that the water between your islands is a disadvantage. Well, you really should look at it as an asset because it's much cheaper to ship by water than to ship by road, by train. You don't have to build infrastructure. All you need to build the ports. But other than that, the water is your infrastructure. It's the highway. That's the highway. You don't need to build that highway. So it's there, much cheaper. Air cargo is the most expensive. So if you feel that you need a lot more air cargo service, well, you may be totally wrong. There are big advantages because it's faster. Water is very slow. That's a big disadvantage. Okay? But each one has advantages. You just need to use the one that basically serves your needs. All right, let's talk a bit about Indonesia. Indonesia is known to be a country with very high logistics costs. I'm sure that you're not surprised by that. So this is a comparison that was done by The Economist in 2006 of Indonesia against some other countries, including your direct neighbors. Right? And Indonesia logistics costs 25% of the GDP. That's mind-boggling. Mind-boggling. In the US, it's 9%. Right? Singapore, 7%. No, fair enough. In Singapore, it's just a city first, but still. All right. Japan, 11%. Malaysia, you certainly can compare to Malaysia, which is really not that different. I mean, I know that it's not, it doesn't have those islands and so on, but still, it's very close to the situation that you have. Even Vietnam is 20%. So you're worse off than Vietnam. Think of it that way. All right. These are examples. Actually, a student of mine told me that the local fruit is actually cheaper to import from overseas than importing from another island. Which is, I mean, talk about the absurdity of the situation. Just because you don't have the infrastructure to relate basically those 30,000 islands together. So is that good for the national economy to leverage the size of your market? No, it is not. Okay? So talk about totally misplaced policies, investment policies. All right. More information on this. And this comes out of a study that was done a few years ago as well, in terms of global competitiveness ranking of Indonesia. Trying to remember what set of countries this was. I think this was in Asia or Southeast Asia, something like that. I think it's in I don't remember what the reference said. But Indonesia was ranked 46. Singapore was 2nd, Malaysia was 21st, Brunei 28th, Thailand 39. Now you're better off than Vietnam. Infrastructure-wise, you're a little bit better off as well because they are 76 as opposed to Vietnam that is 90th. The overall quality and so on, you see that basically Indonesia doesn't look too good on infrastructure. So infrastructure is, by all accounts, holding Indonesia back. That's basically what that says. Okay. There is a direct relationship between global competitiveness and infrastructure ranking. The countries that are most competitive are also globally also the countries with best infrastructure. And if you hold China as an example of economic development as accomplished over the past 20 or 30 years, one thing that is very clear is that China has invested a lot of infrastructure and keeps investing a lot of infrastructure. It's one of the countries of the world that is investing the largest portion of its GDP in infrastructure. A lot of it was really the coastal provinces, and now they're basically putting emphasis on the interior provinces. And that's the case they wanted to make. Development follows infrastructure. Now one can say that the opposite happens sometimes as well. Fair enough. The relationship may be a two-way relationship. This is China. All right, so you have the coastal provinces here, and all of those provinces from Hebei province, a province around Beijing, all the way to Guangdong province down here, are the provinces, the coastal provinces that have grown so much, and basically, that explain basically that 9% growth that China has experienced for the past 20 years, well, 15 years or so, most recently at least. Most of the provinces inland really have not grown a whole lot, just a few percent a year, much more slowly. And really there's a gradient from the coastal area into the interior of the country in terms of the rate of growth of the economy, but also the rate of investment in infrastructure. That gets us into additional consideration for transportation. I did say that there are different modes of transportation that one can use to ship freight from place to place, and the business should always look at the different modes available to them and not settle for trucking if rail is available, but really compare them and basically make an informed decision on the basis of cost considerations. There should be competition between modes of transportation, and often if there is no competition, it may be because of transportation regulation, because of lack of investment, maybe from an entity that is not investing enough, especially if it's a public entity. But in an open economy, in principle, if there's demand, if there's an economy that's growing, there will be companies who basically will invest in that infrastructure and make it possible. I understand the Indonesian government is encouraging public-private partnership to make that happen, and that's highly desirable. Without competition, ultimately, what is interesting as well about the different modes of transportation is that each one has their own intrinsic advantages over different ranges of distances. So it's not as if you had to ship by rail from one end to the other, but you can really use trucking to bring your freight from your plant into a rail center, a terminal basically, where you put it on the rail line or this rail cars, traveling over hundreds of kilometers to a destination, maybe to a port where it's going to be put on a ship, maybe on a flatbed truck to be delivered at the market. Transferring between modes of transportation is always very sticky. It is slow. Often there will be some handling. Okay? Loading a truck with a container or loading a ship with containers is really an operation that is labor intensive, it is slow, and it is expensive. I do need to keep that in mind. Shipping over hundreds of miles or thousands of miles by water is very cheap. It's the handling at the port that typically will be very expensive. That's also the place where there's a lot of infrastructure that's required, and also the place potentially where there may be delays. Those are also the places where document needs to be filed, and there may be a lot of red tape imposed by government regulation that will slow down the flow of trade. So intermodalism is very important. Intermodalism is that concept that basically enables and talks about the articulation of different modes of transportation. Trucking and rail. Trucking, rail, and then water transportation by container ships, for instance. All modes of transportation. Intermodalism is not necessarily for water transportation. It involves as well shipping by air, and particularly high-value commodities. For instance, fruit products would be grown in Indonesia that would need to be delivered in Hong Kong because it's a major market. Probably would be shipped over there, could be shipped there by planes because of the need to deliver food fresh to the market, or flowers, for instance. That's a very well known type of product that requires fresh delivery. So feeder services is very important because often you need to articulate different modes of transportation, concentrate the traffic in order to gain economies of scale. That's very important. Integration is really very important today when we talk about intermodalism. It's more than just the physical, it's the need to be able to bring a container to one location where it can directly be put on a ship. But it's also the fact that you need to have a single rate, quote it to the company, to the shipper. That's often what has made intermodalism successful worldwide, as opposed to having to negotiate different rates with different companies. So the ability to negotiate a pooled rate, a single rate, is extremely important. Intermodalism has led to total reorganization of the transportation systems and logistics systems. It used to be that you had different modes of transportation, you had rail lines, you had roads and so on, different locations, things were shipped in between, and those were basically, that defined basically the point-to-point network, one point to another point. Now we have much more often, in the context of an intermodal network, these kinds of situations with transshipment locations that serve as hubs, which are extremely important, where basically a feeder services from D, E, and F into that transshipment center that allow you to ship at high capacity from that transshipment center to the other one, meaning take advantage of economies of scale. Okay? And from that location, then you can basically split the shipments to final destinations and the other way around as well. So intermodalism and transshipment does not just have a cost implication, but it has also a spatial implication, because you need to find the locations where to place those transshipment centers. And there will be winners and losers. Okay? If you're close to transshipment center as a business, you are at a great advantage. Right? Because you may be able to take advantage of reducing one transfer over businesses that are located away from it. So that's a great asset. So we talk about intermodal change, and so this is a place where there's an interchange, where there's a transfer from one mode to another, from one carrier to another, one company basically to another. This is a place of origin, this is a place of destination, and typically our businesses are scattered into over the entire region, and the shipments to be brought to those locations, concentrated, put onto high capacity transportation systems, transferred over here, and arriving in the final location. And typically different modes of transportation are used here, the feeder routes, feeder lines, and the high capacity lines. So this could be ports, for instance, here, while here this could be just highways, okay? And these are the locations of cities inside of a country, for instance. All right, there are a number of factors that over time have impacted on the organization of integrated transportation systems, and technology factors. Capital investment is very important, because if you need to build those transshipment centers that promotes and encourages really concentration of businesses, because you need a lot of infrastructure. So big businesses are at a disadvantage. So integration of businesses is certainly been a trend in the transportation logistics industry, either by merging or acquisition, or by being part of a larger network of companies in order to make it possible. So alliances, merger and acquisitions, has been important. And in many countries, until either very recently or just a few decades ago, this was not possible. So deregulation has been a very important step in this case. So deregulation in the US happened in the 1970s, 1980s. That's what has made intermodalism really possible. Globalization is a very important element of this, because that creates a market basically for these kinds of new structures and these new kinds of technologies, new kinds of spatial organizations as well. Organized around networks. Take advantage of economies of scale, efficiency, control. Technology is very important in all of this as well, because if you grow the amount of traffic, you also need to manage the freight. You need to know where the containers are. You need to be able to tell your clients where the containers are, when they can expect the container to arrive at the destination. You cannot just take possession of the container and say, oh, well, we'll deliver it in the future, without telling them when. Right? So just-in-time delivery is essential. You need to be able to tell them what window of delivery you can significant price. Okay? And the reason for that is that there's just-in-time manufacturing. I'm sure you learned about some of those things. And manufacturing operations need to be able to count on the delivery of the parts on just-in-time basis, and therefore the transportation system needs to be reliable as well. Intermodal transportation systems have evolved a lot, and here I'm talking about basically containerization and everything resulting from all of this, which is basically sort of the low level of technology that enabled through containerized, standardized boxes, basically to reduce the handling required of all of the freight. This started by the development of pallets, wood pallets in the 1930s, right? But recontainerization started in the 1950s, okay? And took off very quickly afterwards. The first container ships really operated in the US, between the US and some islands of the Caribbean. That expanded very quickly. Transatlantic and all of those things that we know at this point in time. So intermodalism is really not a very old concept. Okay. All right, so pallets, yeah, these are the pallets. Those wood things, it don't have to be wood, plastic can be metal as well, that allow basically to load the standardized amount of freight and to handle it mechanically as opposed to manually by carrying it in bags, things like that. That allows you to load freight into a container and to move in and out of the container much more readily. This is, I think, the very first container ships existed, and that were just a cargo ship that had been converted to carry containers. Okay? Yes, those were the very earliest ones. And I'll show you one of the next pictures with some of the more recent container ships. All right. These are containers, and containers will become in standardized sizes, either 20-foot long or 40-foot long. The advantage of it really is they can be stacked, standard size, they can go on a flatbed truck, and they can be carried very easily as well from rail cars to flatbed truck in that fashion. In the US, what is very commonly done is, because our railroad system is not electrified, and I don't think that in Indonesia it's electrified either, but the big advantage of it is that you can load two containers one on top of the other. That's called double stacking, like here. So this is a rail car with two containers one on top of the other, and automatically basically reduce the transportation cost by something like 60%, because you carry twice the load on the same rail car. One mode of example of intermodalism that exists as well is what's called piggybacking, which is to put on a rail car that you see there on the bottom, on top, trailers. And now two trailers are loaded over there. That's called piggybacking. That's a picture of it. It's less common than it used to be, but it's still commonly practiced. Now, containerization, which is that process of adoption of containers as in the logistics industry, has changed quite a bit over time. Initially, what we had was basically what we had represented there on top. Containerization was really done just between the ports. So basically, the freight was put into the containers at the port, put on boat, on the ship to the destination on the other side of the ocean, was taken out, and that was it. So that was basically using container ports. Progressively over time, systems, delivery systems and routes followed by the ships was changed as well, and different kinds of ports were developed, including gateway ports. It's called pendulum services. I'm going to talk more about that in a minute. Basically, the same ship basically doing a service route between different ports, and sometimes going around the globe, as a matter of fact. And today we have something that's much more complex, that looks much more like this, with inland, the integration of inland transportation center and transmodal operations from over great distances integrating basically the maritime portion of the route as well as the land portion of the route much more seamlessly. This is another view of this, and it's an integration that occurs from the local to the regional to the national. Okay? And the national, these would be the major hubs that interact with one another. Here, these are the local hubs regionally, and then on top of there, this would be, for instance, the local carriers that basically pack up at the origins and deliver at the destinations. All right, I did tell you about the containers with a standardized boxes. You can't see that too well. This is the growth of container traffic, container what's called throughput, between 1980, which is over here, and 2010, which is on the right. So it grew from something like 50,000 units to 500,000 units. So it has been a growth that has been fantastic today. Everything is shipped in containers, even the bulk things, including grain, soy, oil. I'm not talking about gas, but palm oil and all kinds of things like that shipped by containers these days. Rocks, marble, all kinds of things. Some of you may wonder why there's a mention of empty containers there. Well, containers are reusable because they're not disposable. So if they're shipped to a destination, they have to go back to the origin to be reused. And because of the imbalance of trade between countries, sometimes they have to be shipped back empty, and that's a very heavy cost. So the proportion of the number of empty containers actually has been increased dramatically because of the increasing imbalance of trade between the US and Europe on one hand, and China particularly on the other hand. China needs a lot of containers, but they don't import as much as they export, and that's the source of the imbalance. The advantages of containerization are numerous. Standardization is very flexible, it can store things. Many companies use actually containers for storage. Yeah, you don't use warehouses anymore, or not as much at least. They use them for management because these days they have a unique identifier, they have a microchip or RFID on them, which means it's possible to track their movement each time that they pass a gate and detect it. That's for maintenance and for management. Very low cost. It's 20 times cheaper than bulk, okay, because of the reduced handling. It's much faster. Warehousing, I talked about it. It's much more secure as well. Okay. You can also ship refrigerated goods, frozen stuff like meat and so on in containers. The challenges. One of them is the storage. If you have an accumulation of containers at one place like empty containers, that takes a lot of space. And at least in the US, since a lot of the traffic is from China to the US, there is a problem of storage. And that storage is often a problem. There's an accumulation. You don't have enough land basically to store those containers on a temporary basis. Infrastructure cost is very important. The material, the equipment to handle containers is extremely expensive, which is the reason why some ports have difficulties doing it, and then they basically need to find investors basically to provide the funding. Stamping is certainly an option, as I told you before. Management and logistics, empty movement, I told you about this. Illegal trade is a very big issue these days. The same way as you can make them safe because they're sealed and so on. Because they're sealed, you don't see what's inside. But there are some technologies that exist now to scan the inside of the containers to detect, for instance, individuals. Illegal immigrants basically would be hidden in it. In the US, technologies do exist. Containers are scanned so that you can detect illegal immigrants. You can also detect radioactive material, all kinds of other things that the country does not want to see enter the country without being detected. The nature of the trade has evolved a lot from the mid-1990s. This is the composition of the trade in terms of the origin. So the This column here is the trade from Asia to North America. This is North America to Asia, so there's the reverse relationship. This is Asia to Europe and so on. And not only you see that the trade overall has increased dramatically, but most of that growth is actually due to the very first category over here, which is the trade from Asia to North America. And also you will find that the trade from Asia to Europe has grown dramatically as well, and that's this one here. So as Asia developed, and this is primarily the result of China, which has become the factory for the rest of the world. And as we consume in North America and in Europe a lot that is made in China, there has been that increasing imbalance of trade between the two trade relationships. All right, scale economies and containerization is very important. In the 1980s, the typical ships contained 3,400 TEUs. A TEU is a 20-foot equivalent unit. It's the equivalent of a container that is 20 foot long. Right? So if a container is 40 foot long, that counts for 2 units, basically. 3,400 containers, 20-foot containers. Now, I'm talking about ships that have 18,000 containers. So that does represent some constraints in terms of the size of the ports, the size of the cranes, the number of cranes that you need to service those very big ships. Those ships can be unloaded in a matter of a day, basically. So you need a very significant and very efficient crews you need to service those ships. All right, so these are some of the ships that we're talking about. Maersk Line is one of the biggest companies, it's a European Danish company. And so that's what the ship looks like. Okay? And that's an example of the kinds of cranes that you need. See that here you have 6 cranes that basically operate on the same ship at any to service that ship at that particular moment. Alright, the evolution of technology, and again I was telling you that in the early days, in the 1950s, those were converted cargo vessels, as I told you. Then we went on to converted tankers because they were bigger, and this is what they look like at this point. And they keep building bigger and bigger ships. All right, evolution, the different types of maritime routes. As I was telling you earlier, previously it was mainly port to port, and then over time, really, in order to accommodate the fact that ships were bigger and therefore there was not enough traffic between 2 ports, that basically started to serve multiple ports on multiple continental facades, say Asia and the west coast of the US. So once they cross the Pacific, on one coast they're going to service 3 or 4 ports of call. And the same thing on the North American coast. And they do that dependent on the service, like the pendulum that goes back and forth. Okay. Another form of service is the round the globe service. I was telling you that some ships will basically do that, and indeed it's the case. And some of them do stop in Singapore, some stop here in Japan. Actually, not really, I'm not sure about Japan. Alright, this is a map of the world container ports. Some of the biggest container ports are in Asia. And I will show you the ranking. Well, these are the biggest ones. The biggest ones in China. Singapore is the largest one. Hong Kong is on top there as well. Shenzhen, Ningbo, Guangzhou, Busan, and so on. Those are the biggest in the world. This is the list of the biggest ports. So Singapore, as I told you, is the largest container ports. Followed by Shanghai, Hong Kong, Shenzhen. This has been very stable. All Asian countries. The largest European port would be Rotterdam, then you have Hamburg, Antwerp, and the biggest American port is Los Angeles, which is a very big change with respect to the 1980s, where New York, for instance, was one of the largest, as well as European ports. There's been a total shift in the geography of sizes. This is a map of some of the pendulum routes operated by OCL in 2006, which was one of the Chinese companies that provide that service. And they provide a variety of services, one from Barcelona in the Mediterranean, across the Suez Canal, leaves the ocean to Singapore, and then continues all the way to Ningbo in China. Then goes back and forth, other service across the Atlantic,